When we hear the words artificial intelligence, it is easy to picture a walking, talking robot from a sci-fi movie. But for most of us, an encounter with artificial intelligence looks a lot more ordinary, like waking up and glancing at your phone to unlock it. That quick face scan relies on a branch of computer science called computer vision. Instead of a typed password, the camera acts like an eye, recognizing the unique shapes and contours of your face. And when you open an app like YouTube and immediately see a video you actually want to watch, that is an AI recommendation system at work. It acts like a highly observant librarian who remembers every book you have ever checked out, using those habits to guess exactly what you will enjoy next. Broadly speaking, artificial intelligence is a field of computer science with a specific goal: creating machines that can perform tasks that usually require a human brain. This raises an interesting question. Human programmers aren't typing out exact step-by-step instructions for every single video recommendation or face scan. So how do these systems actually know what to do? The answer lies in how we design computers today. We have moved away from building machines that only calculate numbers and started building machines that learn from patterns. If you tried to write a strict rulebook teaching an older computer the visual difference between a cat and a dog, you would quickly fail. You can't simply code pointy ears or fur because those physical traits overlap too much. To solve this, computer scientists use machine learning. Instead of giving the computer a rigid rulebook, they treat it more like an eager apprentice who learns by looking at lots of examples. This process is driven by the data flywheel. By feeding thousands of labeled photos of cats and dogs into the system, the digital brain notices subtle visual differences on its own. The more examples it sees, the better it gets. This method of learning through examples is what allows machines to successfully categorize everything from human faces to complex medical scans. But mastering perception was only the first step. Once a machine truly understands a pattern, it can use that knowledge to create entirely new things from scratch. This brings us to systems like ChatGPT, which belong to a category known as generative AI and large language models, or LLMs. Think of these models as incredibly well-read authors who have studied millions of books to learn how human language flows. These models study how often specific words appear together, using those mathematical probabilities to predict which word should come next to complete an original thought. This chart shows what surprises users most about AI. Looking at the top two bars, we see users are amazed by high-skill tasks. 28% were surprised by advanced coding capabilities, while 22% cited breakthroughs in generating media. We now have computers acting as creative collaborators, fully capable of writing code, capable of drafting essays, and generating art alongside us. Even with all that creative power, generative AI has a hard limit. It can write out a recipe or generate the code for an app, but it cannot go into your kitchen and cook the meal, or launch that app onto a server on its own. That requires a leap to agentic AI. These are systems capable of autonomous decision-making, taking independent action without a human needing to hold their hand. It is the engine behind what economists call the do-it-for-me economy. To work autonomously, an AI agent follows a four-step workflow. It starts at perception to gather information, moves to cognitive to reason through steps, and engages action to complete the task. Finally, feedback assesses the outcome and adjusts future behavior. With these pieces connected, machines can take on complex, multi-step manual tasks completely independently. Giving a machine that level of autonomy naturally leads to a problem of trust. If we cannot see inside the digital brain, a dilemma often called the black box problem, how can we confidently rely on a machine's critical decision? Computer scientists address this through a framework called explainable AI, or XAI. Think of it like showing your work in a math class. XAI is designed to make the AI's internal decision-making process completely transparent to human operators. In an X-ray scan, XAI system creates a visual heat map that highlights the specific cluster of pixels that triggered its diagnosis. This evidence allows a doctor to check the machine's reasoning before deciding on a treatment. We also see this transparency applied to education, where intelligent tutoring systems act as patient, personalized teachers. By constantly analyzing how a student answers questions, the AI adapts its teaching style in real time, providing instant feedback tailored to that specific learner. We have moved from computers that needed a person to tell them how to sort a single photo to systems that can write their own code and manage multi-step projects autonomously. This invisible assistant is already integrated into our daily lives, and understanding how it thinks is the best way to prepare for what it will do next. If you want to keep exploring the systems that run our world, make sure to subscribe for more lessons.